I did this thing. I have a hydrogen molecule with one electron, but then I have a cluster of other hydrogen molecules around it, density making them farther apart or closer together. However, when one electron moves, the entire structure moves, and it causes a ripple effect amongst other structures. This gives an implication of a topological grid. So I tried scaling it with other elements, and with other elements it mathematically adds up, even with different densities of atmosphere. Right, so if I move one and it causes a ripple effect amongst other structures, you have a topological function, a connectivity topological function, not conductivity, connectivity. So essentially, in this model, planets aren't sitting on top of a gravitational blanket. It's more so a electron equilibrium of a topological grid, which is why it doesn't violate general relativity. In fact, it just adds more to it. So here's the thing. You can take a atomic crystal, a crystalline structure, and you can predict the following crystalline structures after it, due to the topological mapping of the electrons, no matter the element. Calculable, scaled, and predictable, even with chaos floating around, only due to the fact that atomic structures have a general shift in direction. So the topology is there, it's just moving ridiculously fast. Right, now we're thinking about entanglement. So if the topological structure is unstable enough for atomic structures to move in one location, enough to cause entanglement in another location, this implies one and two things. Either the point in entanglement is less structured, or the location of entanglement is unstable, therefore the wave ripple from one atomic structure shifting would affect that side of the entanglement. That is the other side of the entanglement. This suggests that light speed and warp travel do not violate general relativity. This also suggests that if we can move the electron at one point, or a cluster of electrons from one point, you can essentially use topological correction for warping or faster than light travel. It's like looking at a glacier. You can hit it from one part of the glacier and another part will completely break. So the electron activity and wave function of the electrons moving within clusters will affect more unstable areas versus stable areas, or areas with extremely high density. The thing is that the topology of atomic crystals can be scalable upwards even to glaciers. So if it's scalable from atoms to glaciers, to even planetary orbital topology, and even oxygen, this might be scalable for tectonic rupture activity. Right, so you have planet on gravitational blanket, but there's nothing to measure a gravitational blanket. So what if it's not a blanket, but a topological grid with an equilibrium?